All right, I'm starting the recording now. Welcome everyone to this first meeting in the fall of 2021 of the AI Ethics Seminar. Our speaker today is Christian Balkenius, who is Professor of Cognitive Science at Lund University, and he will talk about transparency and trust in humanoid robots, a case for non-verbal signals. There will be some time towards the end for questions and answers. I suggest that we keep oral questions until then, but those who have questions in the meantime, feel free to post them in the chat and we will pick them up during the Q&A. So as you can see, we're still doing this over Zoom. In a few months, maybe, we hope to partially switch over to IRL seminars, but for the moment, we do it this way. So I now hand over the word to our speaker, Christian Balkenius. Most welcome. Feel free to share the screen.
Yep. So hopefully you can see my
Yes.
screen. Okay, thank you. Today's topics will be about humanoid robots and what we can do to make them more trustworthy. And this is to some extent in contrast to what many other people are doing within AI and trustworthy AI and predictable transparency and so on. I'll describe this in more detail, but let's just have a quick look at what most other people are doing. So one approach to get people to trust AI is just education, educating people about how AI systems operate and so on. And that's of course a worthwhile goal, to teach people to do things. There are other approaches like trying to increase the openness when it comes to how systems operate, how they function, how they are built, and the plans and goals and everything of companies building things. Of approaches like open source and so on. And the idea is that this somehow increases transparency, and of course it does. The more information you give to people, the more they understand and know about the technique, the more transparent it gets. And to some extent, the goal here is to have systems that are explainable, in the sense that you understand what they are going to do and why, and you know something about their operation. Now, all these things are good. I have nothing against them. But I think it's sort of a problematic basis for building trustworthy signals. And the main reason is that people tend not to care. It's nice to know how things function, but we don't have time for that. We do other things with our time and in our lives. So of course, if we look at open source, for instance, it's fantastic that you can share code. It's fantastic that you can look at other people's code, understand what's going on. But most of us will never do that, even if we could. We don't have time for that. So it's good in itself, but in practice, it doesn't matter very much. And of course, education is good for those who get it, but doesn't matter much for other people. So if I have a criticism of these kinds of approaches, it's that it's a bit engineering centric. It's for the engineer or the engineer-in people that are not engineers, ways to get them to trust and understand AI systems. But in most cases, when we think about trust and trusting mechanical engineering systems or other people, it doesn't really have to do with that. So let's see, that's supposed to be brain, yeah. So I usually trust other people most of the time, but I don't trust them because I know how their brains work. Well, sometimes I do a bit because I'm a cognitive scientist, but mostly I don't. I have no idea about everything that's going on in the brain, but it doesn't really matter. I trust people anyway. And what about sort of engineered objects like a car? I have very little idea about how a car works, but I trust it with my life. I know I'm only like a half turn of a steering wheel from death when I'm driving, maybe a bit more because I'm not very good at it. But still, I'm not afraid, not a bit afraid. In fact, the other day I was talking to my wife and we were discussing whether the steering wheel was actually connected to the wheels in the model car. I'm not sure. I think it's connected to the wheels still. I'm not sure. Maybe not. Maybe that's just a wire on the servo motor or something. But my point is, it doesn't really matter. I'll trust it anyway. And it can be extremely dangerous, but I never think about it as dangerous. So it's not because I understand it or have learned a lot about cars that I trust my car to not kill me. It's for different reasons. So I try to summarize that, and it's something like this. It's based on two things. One is sort of a track record. So far, no car has killed me. So far, I have done mostly what I'm supposed to do. I usually get where I want sooner or later. It's not particularly scary, but mostly this is about having experience of a system. So it's more of a statistical approach. Most of the time it seems to work. When it doesn't work, it does give out certain cues like strange sounds and maybe something sounds a bit shaky or feels shaky when you drive, and then you know it's maybe not working that well anymore. So someone have to check it up. But that's, I say, is one of the reasons why I would trust my car, or for that matter, another person. If a person has been trustworthy every time I've interacted with it, I tend to trust them. Then that's a question whether you should trust them the first time or not, and that has to do with your personality. I tend to trust people as long as they deserve it. But the other aspect is predictability. I trust a person or a system if I think I can predict how it will function in a new situation. And that, of course, depends again on experience. So I think this is perhaps the most important part of it. But I want to be able to predict what my AI system or robot will do in a certain situation. And I want to be reasonably confident that I can do this. And it's kind of fun because I before this presentation, I just looked up trust in the psychology dictionary, and it says exactly that, which was sort of nice to see that the key factor to trust is not intrinsic honesty of other people, but that predictability. So I sometimes joke that very greedy people are very trustworthy because they will do everything for themselves. Someone which is very self-centered, that's also trustworthy. Not necessarily nice, but there's something that makes them predictable because you know what their goals are. And that seems to fit with this definition also in the psychology dictionary. So my case then for robots and how to make them trustworthy really has to do with making them predictable. And let's see, nothing happens. Press another window like that. Okay. So one nice thing about robots compared to other AI systems is that they are embodied. They have some sort of, not necessarily a body, but something physical that you can look at, physical things that do things. They operate in the world, and that makes it possible to see what they are doing if you're lucky. So actions are visible, and mostly the effects of what the robot is doing is what is changing in the environment is obvious. If you have a robot moving around along a corridor or something with some package, you know it's moving a package because you can see it's doing it. It has nothing to do with the inner working of it, but it's sort of an overt behavior, and you can see what's going on. If you have industrial robot, at least in some situations, you can see it's building something, putting something together. And that sort of makes it more easy to understand. So what I want to argue today is that we can use these features of robots, the fact that they are physical and act in the world, to make them more predictable. Because it's not necessarily so that we can predict what will happen in a robot. They could operate in a very sort of complicated way. They're doing things, but you really don't understand it. You have similar problems actually with autonomous cars. So they tend to do exactly the right thing most of the time, at least, but they are not really communicating what they're doing. So if an autonomous car drives around perfectly, follows every traffic rule and so on, and they're still a bit scary because they don't show their intent, they don't show their goals. Humans are quite different. When we get to crossing, we will slow down, move our heads around, look in different directions and so on. And other drivers will look at us and see where we are looking. In fact, there are studies on that show people use that information quite a lot, trying to have other drivers see me and so on. While most upon autonomous cars, where you're just driving, even if they're doing it perfectly, there's nothing to show what they're actually trying to do. They don't necessarily slow down before a turn if it's not necessary, for instance. But then, of course, you could get autonomous cars to do this if you wanted them to communicate, and also robots, obviously. So what I'm talking about today mainly are these robots, humanoid robots that we build in the cognitive robotics lab in Lund. They're all called EPI, and that was short for epigenetic robots. And epigenetic robotics is sort of a direction within robotics that looks at developmental processes and how you can imitate some behaviors of children and how they develop in robots. They're all the same. I think we have 7 or 8 or something of this right now. Slight differences, mainly the colors of the ears. So they call like epi black and epi green and so on. Turns out that it's a really good idea to have some difference in different robots. Otherwise, you won't remember who's doing what program it's running and so on. So in these robots, we try to look at how they can communicate about their sort of goals and intentions and so on in such a way that people will understand it implicitly. So, because that's one of my main points here today, is that if we do this correctly, we don't need to educate people about what the robots are doing. People don't need to be interested in the robots even. They will understand them anyway and maybe come to trust them. But at least there should be the information, the cues that makes it possible for people to predict the behavior of the robots, even if I'm not particularly interested in it. So if we look at humans and how we do things, we can start not at our actions, but in the environment. So for instance, when we are trying to do something like here, we get the relevant objects, place them in front of us, more or less organized. And in this case, for instance, I don't have to explain what's going on here. You don't even see the person doing something, but you see the environment, but there are a lot of stuff here. And it's clear that the goal is to bake something vanilla flavored, I think I see. We're not exactly sure what, but something. Because all the stuff is in the environment. Because of that, we don't need to explain. We don't need to tell anyone verbally, I'm making a cake or whatever this is supposed to be. You see from the objects or around the person that they have a particular goal. And this is not a very specific case. This is nearly always the case. When we have things that we interact with, we tend to get them first, place them around us in some systematic way before we do whatever we're trying to do. So very often there are this kind of contextual or environmental cues that that tells us something about what the person is trying to accomplish. So this is just the environment. Then if we look at actual person doing something, yeah. So one very important thing about all human and biological activities, it takes place in space. Things are at certain locations and so on, and all our actions, our attention and so on is focused on particular locations. So the most obvious cue to human goals is the direction of gaze, visual attention and so on. So for instance, before we pick up an object, we will nearly always look at it. And if we look at the attention of people, it typically precedes an action. So if we see what people are looking at, we can figure out what they are about to do in most cases. And this is so connected that it's really hard for us not to show what we are attending to. And you probably all have tried that if you're eavesdropping on someone trying to look in the other direction. As soon as you lose focus, you will immediately turn your head towards them. So your head will and your eyes obviously will follow your attention, and you have to explicitly inhibit that for it not to happen. And of course, if you're listening, the ears don't move. If you're human, if you're a dog, the ears will move as well. So you can look at the ears of the dog and figure out what it's listening to. And just for dogs, it's really hard not to do that. I think it's fun. I should talk about horses. I think it's really fun if you see horses jumping over a fence. In most cases, they will actually move their ears towards the fence, listening to it. But there's no sound. But the ears will still move in such a way that it directs its attention towards the fence before jumping. And when it doesn't do that, it's very likely to fail. So this is just an example of how the body shows the direction of attention. So in a horse, it won't move its head very much, and the eyes don't move very much, but the ears move. For humans, the eyes moves a lot, and the head follows the eyes most of the time. So the alert movement of the body tells us something about what we're attending to. And just as the very trivial example is, I think the robot looking at something, and I'm telling you that it's looking at the paper here, but I don't have to tell you. It's entirely obvious. Even though the tracking is not very good, this was like the first test of something. It's just a video I had lying around, but it demonstrates this fact that it's obvious that it's doing because the body tells us that it's looking at the paper. I have no idea what's there on the paper. I don't remember. But anyway, another way to communicate a goal is, for instance, in interaction. I think this example is fun because it's a bit unusual. So here, I'm just moving the robot around. Hopefully, you can see it. Let's see if it stops automatically. I have to press something. Let's see. Yeah. Okay. So I'm just moving the head of the robot. And the point here is it's not doing anything. It's just trying to put the head in the same orientation again. But because it's compliant that you actually can move it, it also shows that it's trying to be in that position. Most robots are stiff all the time. You can't move them at all. And you never know whether they are sort of just not functioning, completely stiff. But here, because it moves back, you get the information that it's sort of intentional. It's wanted to point in that particular direction. So again, it's a very, very trivial thing, but in the interaction, you get a form of communication between the robot and the human here. Another just as trivial example, but it's also fun. Here, for instance, you have a robot. I move an object around. You see looks at it, and then tries to pick it up. No one is surprised that the hand moved towards the object. And the reason is that the robot first looked at it. If it didn't do that, the hand just started to move. And if there was more than one object, obviously, then you couldn't predict what was going on immediately. But here it's obvious because it mimics the way people do this. Of course, we can pick up things without looking at them or while looking in a different direction, but we hardly ever do that. So the gaze is just the first thing, and the hand follows the gaze in nearly all situations. So, the point here is that humans and animals, for that matter, are kind of leaky systems. It goes on, leaks to outside. And even when we are doing things that are not with the external world, when we are thinking about things and so on, our head and eye moves and so on, we're nearly never still. Or even a nice experiment that shows that when we're thinking about looking at something, the eyes move, not in exactly the same way as if we actually looked at it, but very similar ways. So it's like even when we're accessing something in our memory, our body moves in such a way that it resembles being in that situation. And you probably all know the experience of waving with your hands when you're talking on the phone. I mean, there's no one to see it, but you still do it. So all these overt signals, they are there even when they're not really needed, perhaps. And of course, looking at things and picking things up is a special case, but we do a lot of this. And once you realize this is the case, I mean, it's much more interesting going to a cafe and looking at people. Okay, you see all these kinds of things all the time. And you can figure out what people are thinking about sometimes, at least just by looking at them. Because they're leaking so much information. It's really hard not to do. And the good thing about it is that if we can get robots to do that, then they will be more predictable. Another kind of sort of leaks, but sometimes intentional, sometimes not. Things can call intention movements. And people do this all the time. But apparently it's impossible to find pictures of it. I was looking around the web, found absolutely nothing, but it happens every second, everywhere. And that is movements that you do before an actual action to show that you're about to do something. This can be moving around in your chair, changing maybe the weight in the chair in such a way that it's easier to get up. And you can see that very clearly. If someone wants to leave a meeting, they will change their posture as a first step towards standing up. And maybe they won't do that for another 10 minutes because they can't go away for some reason and so on. But these particular movements give off the information that they are about to do something. And there are millions of those, maybe not millions, but there are lots of those different movements that people do, especially in changing posture and so on. And my favorite is perhaps when people start to move their feet during a meeting, like almost walking, which signals that they want to go or they want to leave. They don't necessarily do it, but they are thinking about leaving, and when they're doing that, the feet start to move. And again, a lot of those, and we all pick up on this, but mostly we do it unconsciously. It's possible to become conscious of it, and then your world changes. But everyone uses this all the time, both to express things and also to understand others. So, for instance, if you want the meeting to end, you can just move around like this in your chair, like I did right now. You're looking at me, and that means that I get ready to leave, but I won't say lean back again. So I'll talk a bit more. And all these very subtle things contain a lot of information. Now, sometimes we do this really intentionally, and people have studied something that's called mavorees in infant directed speak. That is when when a parent talks to a child in a slightly exaggerated way. So they may talk slowly or stress particular words in various ways. So to gain the attention of infants. And so this is a dog. I can't do it correctly. I need an infant for that because we do it automatically. And it's really silly when you do it without the infant. But when it's there, it works well. So you sort of exaggerate the language, make it easier, and try to stress whatever you think is important in the sentence. And of course, the infant picks up on this and it supposedly makes it easier for it to understand what you're talking about. Now that's a special case, but recently people have started to look at something else I think called Emotionless, which is that when we do actions directed at other people, we do the same thing. We exaggerate the movements. And going back to the cafe, it's really fun to see how people drink coffee when someone is observing them compared to when they are alone. And again, it's impossible to get pictures of that because no one is alone when people take pictures of them. But if you manage to see this at some point, you can appreciate it. So when someone is around, you're not drinking coffee, you're drinking coffee. You're moving in a different way to show everyone that you're drinking coffee. And we do this unintentionally, I think, and unconsciously. The movement is different. If you're alone doing the same thing, you'll do the most effective movement for drinking coffee. But when someone is looking at you, you'll do it differently. And this is something kind of fun. We've also, I played with that outside the train station in Lund, looking at people walking over over the street. And once I realize someone is looking at them, they start to walk in a different way. You can see the movements immediately changes. So just to have one example, you shouldn't do that too much. I think people will get angry, but it works well for a while at least. But this is something we do unintentionally when people are around us, but we can also do it intentionally to communicate that we're doing something like, I'm drinking coffee. That could be the message. You don't have to say it, you just do it in a particular way. But it can also be something else. You can initiate.
I'm not hearing you now, Christian. Is it just me?
So it could be, for instance, you can do an action in a way that invites other people to collaborate with you. And it turns out that if you move in a certain way, people will collaborate, and you move in other ways, they won't. So for instance, I can show a social intent to initiate a joint task. And this is something we tried to reproduce in the robot. And we did a study just before we were locked down for the COVID. So we didn't really finish the whole experiment, but we did most of it. We had, at least we had 44 subjects. The idea was to have more, but we have to stop it after 44 participants. So the idea was to see if we could manipulate the way a robot moves in such a way that it would invite sort of social interaction. So each participant here was just involved in a single trial, and what the robot did was just stand by a table with a human in front of it, and the robot would just pick up a block, place it in front of a person, and the task of the participant here then would be to take another block and put it on top. So extremely simple. The robot moves a block, and you're supposed to put your block on top of it. And what we wanted to look at was how people would do this. Would they do it in sort of just instrumental way, where they just move a block in the most efficient way, or would they do it in a more social way, exaggerating the movement? Would they look at the robot, maybe trying to get eye contact and so on? I'll show you if this works because I just got some clips out of a longer sequence, but with some luck you will see the right part of the clip. So the robot did this in 2 different ways, and here's the first one, I think. No, here maybe. So this is sort of just an instrumental movement. The robot just stares into the front and moves to block like that. In the most efficient way for this robot. So that's no exaggeration of the movement, no attempt to social contact, and so on. And then we compare that to different movements, and here I'm not sure you'll see the right one, but let's hope so. So here it picks up and it moves a bit more than it has to, just a little more towards the person. The idea here was to probably see a failed attempt later on here. And just move to the next one. But the point is that the movement is a bit exaggerated. So the torso of the robot moves. The robot still doesn't look at the participant. So it's not an attempt to get sort of social gaze or eye contact or something like that. It's just staring straight ahead. But the movement is a bit more exaggerated. So it mimics how people do the social movements. And what we then looked at was how people did their action afterwards. And I should have shown you a picture, a movie of that, but I didn't include it here. But so we looked at whether people would use just an instrumental movement, doing exactly what they had to, or whether they did something more, a more exaggerated movement. And that we call here a social movement. And it turns out that in 90% of the cases where the robot did this exaggerated movement, people would do that as well. So it was kind of mimic the kind of movement. I didn't do the same thing, obviously, because they're humans and have much more degrees of freedom. But I did lift the object more than they had to, for instance. On the other hand, when the robot did just a simple movement, only 30% of the participants would do this sort of more social thing. So we interpret this as if the robot managed to invite some sort of social interaction by doing this more inviting movement. And as you saw in the movies, they are extremely subtle. The difference is not very large, but it's apparently large enough to get this reaction. We also looked at how much the participants tried to get the eye contact. And that also increased greatly. No one looked at the eyes of the robot when it did the sort of plain movement, but when it did the more social movement, quite a lot of the participants tried to get eye contact with it, even though it doesn't react at all to that. They also tended to look at the eye or the hand of the robot more. So it looks as if people are sensitive to this kind of movements. So just some conclusions here. This kind of social movement, if you want to call it that, or motorist movement, does give rise to some sort of social priming. And the participants seem to be interested in collaborating rather than just doing the task we told it to do, based on sort of the things we were looking at here. So this is just a very simple, but I think first demonstration of this. And what we think is that this is something that could be used to simplify the human-robot interaction if we do this more consistently on not just little movements like this, but basically everything a robot do. So if it wants to interact, it can show that in this way. Now, just a completely different thing that we've been working on, which are now kind of non-verbal signals, and that is looking at the pupils of the robot. And the reason for this is two reasons for this. One is that one of my collaborators, he was playing around with an iris because he thought it was a nice mechanical gadget. But then we realized we could try to see if we could build eyes for the robot with an iris, because we know that people use the size of a pupil to communicate with other people. And we are sensitive to pupil changes, but we have no idea that we are. It's completely unconscious. I've probably heard about people increasing their pupil size when they see someone they like. So recommendation, if you're dating someone, try to sit in the direction so you don't look out the window, because then your irises your pupil will decrease in size. So you will look as if you don't like them. If you look in from the window instead, your pupil will be larger, and you will look as if you like them, and people will like you more as well. I'm not sure this is actually studied in such a setting, but we know that the pupil of people do increase when we're looking at something we like. Of course, the first studies were using pictures of naked people, but it works even with a clothes on. It's a way of indicating that you're aroused, and people do pick up on this. Which is fantastic. And not only that, it seems that people mimic pupil movements. So if someone is increasing their pupils when they're looking at you, you tend to do the same thing. So what you see in this not that one, but in this picture, and it's not really changing here. Maybe it will here. Here are the eyes we built for the robot, and it's mainly Birger Johansson, one of my collaborators, who put these together. So you see sort of mechanical iris, and there's a small servo motor with a gear moving this around. And we thought it was important to do this physically, because it seems that if you just have an image of something, people don't take it seriously. If it's physical, it's very different. So just to show you what this looks like in the robot, I hope you see the movement. Here it's sort of more subtle, more like what it would look like in the human, perhaps. The eyes are of course much larger here. A rather small movement. But because it's physical, we tend to sort of react to it instinctively. And it's a bit hard to study. We see when students are playing with the robot, if the robot do something like this, and maybe I'll show this picture instead of over here, it's a bit more exaggerated. It seemed to move, so let's see if something happens. You know, yeah, okay. So we know this will cause a reaction in people, because when students play with robot and it does something like that, they will immediately go and think like, oh, it's so cute, or something like that. So they really react emotionally to this. The only strange thing is when we try to do this in experiments, we don't get that strong reactions. But so it's possible that the person reacting to this also will need to have some sort of social connection to the robot. That's certainly true when it comes to pupil reactions in humans. We're much more sensitive to it in people we know. So maybe the students who kind of knew the robot were more sensitive to it. But again, it's really hard to study in that more general way. But we can use it in interaction. So here's one example of a robot looking at something, and this is from an experiment where it's supposed to be interested in things. So it's supposed to show that it's interesting in the picture. And we tried this in a more experimental setting to see if people would react to this, if they would think that the robot likes whatever it's looking at. And we haven't analyzed the data yet, so I'm not sure it works for real, but the feeling we get looking at this is that the robot suddenly gets interested in whatever it's looking at. Let's see. And here it looks a bit more natural also, the movement. I think has to do a bit with the lights in the eyes as well. So this is just some small things we're working on. Right now we're working on blinking as well. Again, that's something that we tend to use much more than we think. People blink, they blink spontaneously, but it also indicates how nervous or aroused you are. And blinking is also synchronized to various events. So if you're looking at a movie, for instance, you tend to blink when the scene changes, or when, like, the main character will leave the image, then you'll blink. And also if you're listening to a story, someone telling a story, a certain way, places in the story where you're more likely to blink, when like an end to a part of the story and so on. So even if it is random, in many cases we also communicate using blinks. And for the robot, I don't have that in the movie because it's rather uninteresting. We just turn off the light for a fraction of a second. But it has the right. That's the right thing. You feel it's actually blinking. If you look at this robot, it feels like it's staring because it's not blinking. So it's not something that is sort of arbitrary. If you don't blink, then you look as if you're staring. So it's something that we want to add to a robot just to make it a bit less threatening. Okay, so that was sort of mainly about this robot, and I just want to contrast this with some other projects, just to show what we're not trying to do something like this. So this is a really funny robot where they try to get the robot to express different emotions and so on. And this is not at all what we're trying to do. For one thing, why should a robot express emotions? It doesn't have emotions. I mean, it's more or less fooling people if they think that the robot is happy or surprised or disgusted or sad or something like that. There may be a place for this in some situations, but emotions are certainly not the place to start to get humans and robots to interact better. Basically because it's built on a lie. It's built on trying to get the robot to show things that are not really there. Even though I think this robot, for instance, is really nicely done and does fantastic gestures and so on. I don't see that this is where we should start to for instance, make a robot more trustworthy. This is rather the other way around. A robot that shows emotions without actually having them are actually not trustworthy. Here's another example of this. Here we have a nice robot, Cosmo, a really nice, like a little toy with a face that can do different expressions and so on. And again, this is great, but these are not really connected to what's happening inside. It's just a display of something that is supposed to engage people emotionally, and that's fine for a toy. But I don't think that's good for a robot that is used for some utilities. Then it should not engage people in some sort of unnecessary way. It's not that we need to have a relation with a robot. It's a tool that's supposed to do something useful, but it should do it in such a way that it's easy for a person to understand. So that it is as less as possible for a person to understand. Okay, so just to conclude so far, my main point here is that non-verbal signals make humanoid robots easier to understand. That's actually the only thing I wanted to say, and that makes them more predictable and also more trustworthy. Trustworthy because they are predictable, and predictable because we understand what's going on without really trying. And I should maybe also say finally here that this does not mean that I think robots should be humanoid necessarily. When we study this, it's good to have a robot that is a bit like a human with arms and head and eyes and so on. But that's not really the critical thing. The critical thing is that it has this kind of movements that shows what it is about to do, that indicates what's going on inside it in the sense of that shows what kind of goals it has. So it could be a robot that looks completely different as long as it has these properties. And I think in most cases, we have no need for a humanoid robot. I mean, it's fun, but it's not necessarily the best robot for one particular task. It's good when you study these things, but I think in practice, in the future, we would like robot that looks very, very different. But they can still use this kind of cues. And then getting back to the cars, the autonomous cars that you can't understand, if they move slightly different, accelerated, decelerated, turned, and so on in a slightly different way, then that could make them much more predictable and also much more less scary, I say. So that's basically what I wanted to say, and I just wanted to acknowledge that some people helped with this. Many of the ideas here are developed together with Inga Brink. Pierre Johansson, he has worked on much of the robots, and the rest are here are PhD students and master students that have been involved in these different things. So with that, I thank you so much for your attention.
Thank you very much, Christian. This is super interesting. Do we have any questions or comments from the audience? I saw there was a comment from Teresa in the chat. Do you want to ask out loud?
Yes, it was mainly just emotions as fear could be used as to show that something is dangerous, just to emphasize a warning when communicating with humans. So I think that would be easier to understand than that is about to be dangerous for you. And instead, the robot expresses some kind of fear, which would not be that the robot is afraid, but you should be afraid.
Yeah, no, I agree. There are certainly cases where sort of emotional expressions can have a function. And especially if we understand them. In many cases, we don't understand what the robot's trying to do until someone tells us that this is supposed to look angry or afraid or something like that. But that's certainly a case where used correctly, that could be useful.
Yeah.
So I completely agree.
So when you talked about robots not having emotions, I begin to wonder, what are emotions really? You could imagine, let's say, an autonomous vehicle that in certain complicated traffic situations where something dangerous seems to be happening, they enter a crisis mode or a heightened alert mode or something. Could that not be thought of as a kind of fear?
Well, yeah, yes, so actually, I've been interested in modeling emotions and novel computational models and robots too. And I think a lot of things that has to do with different states, being in different states, and especially changing your evaluations of stimulus and so on is closely connected to emotions. So when I try to model it, I used to say that I model sort of the function of emotions, not the emotions themselves, because when most people think of emotions, they think about the experience, the sort of feeling, internal feeling, and the conscious experience of emotions. But if we throw that aside, which I think we should do in most cases, then there is a role for it, definitely. And especially if we look at things like reinforcement and reward and punishment and so on, it's closely connected to emotional systems. So they're interested as mechanisms for obtaining things, but I think that's very different from sort of our experience of it.
So you're suggesting here maybe a distinction between an essentialist and an instrumentalist notion?
Yeah, in a sense. That's why I think it's sometimes problematic to talk about emotions in machines, because people interpret it in a different way. So it could be something like just a reward signal and a reinforcement learning system that operates just like a positive emotion, but when we experience it, it's something else, or
Right.
something in addition. Rather, maybe robots will get us at some point, but right now I think it's misleading to talk about it in that way.
Do we have further questions or comments?
I wonder, sorry. Oh, I wonder if you have studied the traffic situation and people's behavior in different culture, for instance, compare the traffic situation when people's behavior in Sweden compared to Dhaka or in India and so on, because they really do behave differently in these countries. And how do you can you comment a little on that, please?
Well, I can speculate.
Okay.
And we shouldn't take this seriously, but I think one reason for different behaviors in traffic, especially, is how likely you are to meet the same person again in traffic, and we have to do with other social interaction as well. So if you're never going to see the same person again, then you're more likely to do something that is not too nice. But I've seen I have two interesting examples of things. One is I saw a movie from India where the train was passing the street. Because of that one lane, the traffic stopped, obviously, because they couldn't go through the train. But during that time, the other lane that was actually going the other way around filled up completely, because everyone tried to optimize their own position relative to the train. So that was good, like a sort of minimal optimization for them. But of course, when the train was gone on the other side, they did exactly the same thing. So nothing happened. No one could move after that. So it's maybe doing more of a local optimization by looking at the whole sort of traffic system when we try to decide on what to do. Another nice observation is actually when I was in Palermo, where the traffic is interesting, to say the least. And there, the main motivation seemed to be that you don't want someone to run into your car. You do whatever you want, but if someone tries to move too closely, you move away. So that was one situation I thought was really interesting. There were cars filling up a complete street. And finally, the first car started to move backwards. And what happened then? Everyone backed up. And I interpreted it as everyone tried to save their own car. So I started backing. And that worked very well. And I'm pretty sure if that happened in Sweden, no one would move. Because here we know, I think I'm right, I can stand here. I'm not supposed to go in that direction, so I'll just stop. And I think that's kind of different mentalities that make people behave differently. And of course, just as a third speculation here, it seems that in countries where maybe some groups are more oppressed than others, they tend to drive more aggressively. So that may be one way to sort of express yourself and so on. But this is just speculations.
Any other questions?
Yeah, I have a question. Oscar McGregor from the University of Skövde. This is quite a different, it's not such a conceptual question like the other ones. I'm currently doing some work with, among others, a colleague who's also listening to this meeting now, about ethical, like working with the ethics of experiments in robotics and AI before you actually perform them. And we've been looking at, I don't know if you're familiar with ALTAI, the European Commission's assessment list for trustworthy AI. I was just interested in asking about whether you and your research group have used anything similar to this, or perhaps even ALTAI itself, or like what your work has been with the ethical side of things.
Yeah, So we have not worked with that specifically. And sometime I think a lot of the things that the EU is doing now is good, but sometimes a bit misinformed. But then, I mean, otherwise for experiments, you have all the usual things with ethical committees and so on that you have to go through, like in all other kinds of experiments. So I'm not sure how much AI is a special case here.
Mm.
Yeah, so that's my short answer to that.
If we have time, could I ask you to maybe expand a bit on what you think is misguided, just very briefly, about since you mentioned it?
Yeah, okay. Yeah, it's a long story, but maybe my main point is it very often feels like they think the technique is finished. That AI is supposed to be like it is right now. I mean, it's not stated that way, but I think that's my main objection, that it can be completely different in the future. So much of the discussion is about current learning systems and biases and so on, which is of course a good thing to discuss, but I'm not sure that will be how we view these systems in 20 years or something like that. But I would need much more time to elaborate on this in more detail.
Yeah, thank you.
Did anyone else want to ask something? I had one more question concerning trust in general. So you're talking about various ways of enhancing trust, but maybe given the performance of the machine, maybe it can get too much trust. Let's say that you have extreme trust in your car. That might cause you to become a sloppier driver, for instance. Is this a concern in robotics?
No, I don't think we've been thinking about that, or if anyone has done. But it is a good point, obviously. So it's not something we looked at explicitly, and I don't think anyone has actually done that.
One way to say this would be that it might generally be good to make robots more trustworthy. It's hard to see how that would be wrong, but it could be bad to make them more trusted without increasing the trustworthiness.
No, that's certainly right, and I mean, it's definitely not a problem right now, but it might become one at some point. And of course, it's always with engineered system, but humans as well. That, I mean, even if you think you understand someone or something, then suddenly something happens and they behave in a different way. Same thing could theoretically happen to robots. Maybe especially if you have learning systems where you really can't test all situations. So there's always a risk you end up in a situation where something completely disastrous happens because you couldn't predict it.
Another issue with humanoid robots is the uncanny valley phenomenon, when they become too human-like for people's comfort. Looking at your pictures and movies here, it seems that you're not really approaching that regime, or are you?
No, and that's intentional. So and that has also to do with kind of honesty, that the robot should not pretend to be something else. I have myself been fooled for like 15 seconds by a humanoid or android robot that looked like a human at the conference in Japan. I thought it was a human. I wonder why so many people were standing around it, because it wouldn't do anything interesting. It was presenting something, talking. And then I suddenly realized that was not a person, it was a robot. And I can't see the point in that. I mean, it was fun, but why would you want a robot to pretend to be human? I think the humanoid form can be useful just to study sort of interaction, and it's more natural to map human motions and behaviors onto a human or robot. But the idea should never be to make it try to fool people by this human. So the design here is what it should look cute and stupid, because that's what it is. At least stupid. I'm not sure it's cute, but anyway. And by having it has a proportion about over 10-year-old child, which won't give people too many expectations that it would be super intelligence or anything. So it's kind of give an impression of being a bit like it is. It's actually much more stupid than a 10-year-old child, but anyway. So it's intentionally made like this.
And I think with that, we're out of time. Thank you again very much, Christian, and thank you to the audience for participating.